That shiny electric car gliding past you in silence, wrapped in a halo of zero emissions. What if the factory that built its battery is, right now, pumping black smoke into the sky? Here's the question that's going to bother you for the next 20 minutes. If building a solar panel eats up more energy than that panel will ever generate in its entire lifetime, is it still green? Or have we just been fooled by a good marketing story? Stick with me, because by the end of this video, you'll have a detective's toolkit for spotting exactly when a technology is lying to you and when it's telling you the truth. Let's start with the con artist's favorite trick, showing you only one frame of a movie and calling it the whole story. When a company tells you their engine is 90% efficient, that's true, for about 5 seconds of its life. It says nothing about the diesel burned by diesel trucks to dig up the metal, the energy spent shipping components across oceans, or the smokestacks powering the factory that assembled it. Engineers have a name for judging the whole movie instead of one frame: life cycle analysis, or LCA. It means tracking a technology from the mine that birthed it to the landfill or recycling plant that will bury it, cradle to grave. But this is where things get interesting. There are 2 classic traps that even smart people fall into. Trap number 1, incomplete information. A machine can look brilliant on paper, say 90% efficient the moment you flip the switch, but the fuel that feeds it was produced through a wildly wasteful process upstream. Judge only the visible slice, and you'll be fooled every time. Trap number 2, shifting the mess somewhere else. Imagine a company centralizes its manufacturing into one giant, hyper-efficient mega-factory. On paper, efficiency goes up, but now that product has to travel thousands of kilometers by truck to reach customers, and all that fuel burned in transit quietly cancels out the savings. You didn't solve the problem, you just moved it out of frame.
So how do engineers actually audit a technology honestly? They walk through 8 checkpoints from birth to burial. First, resource extraction. How much diesel do mining machines burn just pulling raw material out of the ground? Second, raw material transport. The pipelines moving crude oil, the trucks hauling coal. Third, material conversion. Refining crude oil into gasoline. Fourth, final manufacturing. The energy a factory spends actually building the car or the turbine. Fifth, distribution. Getting the finished product into your hands. Sixth, management and sales. Yes, even the energy to heat the corporate headquarters gets counted. Seventh, infrastructure. The roads and power plants that had to exist for the whole system to function in the first place. And eighth, decommissioning and recycling. How much energy does it take to tear the thing apart once it's worn out? Only when you add up all 8 stages do you get an honest answer. Skip a step, and the number you're bragging about is fiction. Now, here's a sharper tool, one that cuts through greenwashing in a single number: EROI, the energy return on investment. Think of it like a bank account. You deposit $100 and withdraw $110, that's a win. You deposit $100 and only get back $90, you're bleeding money. And no amount of clever accounting changes that. Energy works exactly the same way. If extracting oil from deep beneath the ocean costs you the energy equivalent of 10 barrels to bring 100 barrels to the surface, your EROI is 10, a 10-fold return. That's a genuinely profitable trade made freely by companies betting their own capital because the physics and the economics both check out. But flip it around. If producing corn-based biofuel requires so many tractors, so much fertilizer, and so much factory energy that the fuel you burned to make it exceeds the energy content of the fuel you end up with, you haven't created energy, you've destroyed it, while collecting a subsidy check and a press release calling it green. EROI is the lie detector that no slogan can beat. But raw energy math isn't the whole story either, and this is where things get genuinely complicated. A project can look phenomenal on an energy balance sheet and still be a disaster if, say, it destroys an entire river ecosystem in the process. So engineers reach for something called multi-criteria analysis, a way to weigh competing values against each other honestly, the same way any rational person weighs price, quality, and risk before making a decision instead of pretending only one number matters.
The formula looks like this. The score for option I equals the sum across every criterion C of the weight of that criterion multiplied by the score that option earns on it. In plain English, how important is this factor to you, multiplied by how well this option performs on it, added up across everything you care about. Interestingly, when major analytical bodies compared their weighting systems, nearly all of them converged on the same conclusion. Global warming potential consistently ranks as the single heaviest factor, accounting for roughly 28% of the total decision, more than cost, more than land use, more than almost anything else on the list. That's not a political opinion baked into the math. That's what happens when you let people rank their own priorities honestly and then average the results. Now let's talk about the actual magic trick: optimization. The art of finding the single best answer buried inside thousands of possible answers. Every optimization problem starts with an objective function, something you want to minimize, like cost or pollution, or maximize, like profit or output, and a set of constraints, the hard limits you can't cross, like a power plant's maximum capacity. Here's a real example, and it's worth paying close attention to because this exact logic runs underneath every electricity grid on the planet. Suppose a city has two power plants to choose from. Plant 1 is cheap, 1.5 cents per kilowatt hour, but it can only produce 6 gigawatts, no matter what. Plant 2 is expensive, at 3 cents per kilowatt hour, but it can add another 4 gigawatts on top. The city needs 8 gigawatts. What's the smartest way to meet that demand without wasting a single dollar? The answer, and this is the elegant part, is that the market-efficient solution isn't pick one plant, it's this: squeeze every last drop out of the cheap plant first, all 6 gigawatts of it, and only then top up the remaining 2 gigawatts from the expensive plant. You never pay expensive plant prices for power the cheap plant could have delivered. Voluntary competition between two suppliers, combined with a hard capacity constraint, produces the lowest possible cost automatically. No central planner has to dictate the split. The math derives the right allocation on its own. Written as a formula, you're minimizing a cost function, 15,000 times the output of plant 1 plus 30,000 times the output of plant 2, subject to the constraint that their combined output meets or exceeds 8 gigawatts. Plant 1 never exceeds 6, and Plant 2 never exceeds 4. This unglamorous little equation is quite literally the backbone of grid management software running in control rooms around the world, coordinating thousands of competing generators every single second to keep your lights on at the lowest possible price.
There's one more detective tool worth knowing because it answers a question that trips up entire governments. National electricity consumption just dropped. Should we celebrate? Why did it actually happen? This is where Divisia Analysis comes in, a way to split a single number, consumption went down, into its true underlying causes. Was it because people and machines genuinely got more efficient, the intensity term? Or was it because heavy industry, like steel manufacturing, shut down and got quietly replaced by lighter industry, like software, the structure term? These sound similar on the surface, but they tell completely different stories. One means technology is winning, the other might mean an economy is hollowing out. In the real-world case examined in the source material, the drop in consumption was overwhelmingly driven by efficiency improvements, not by industrial collapse, meaning the technology itself was doing exactly what it promised. That's the difference between genuine progress and an illusion created by economic disruption. So here's where we land. You now have 4 honest tools for cutting through hype. Life cycle analysis tells you the full story, cradle to grave, not just the flattering highlight reel. EROI tells you in blunt numerical terms whether extracting an energy source is even worth the energy spent doing it. Multi-criteria analysis lets you weigh competing values, cost, emissions, safety, without pretending only one of them matters. And optimization shows you how free markets and hard constraints, working together, arrive at the cheapest, most efficient outcome without anyone needing to force it.
None of this requires taking anyone's word for it. It requires measuring things honestly. And once you do, the technologies that survive scrutiny earn their reputation, and the ones propped up by good marketing quietly don't. In the next episode, we're stepping into one of the most fascinating corners of this entire field, energy economics. We'll look at how time changes the value of money and how billion-dollar energy projects get justified or exposed once you run the real numbers. But remember this above all, if you want to actually save the planet, step 1 isn't slogans, it's measuring things correctly. Subscribe and stay energized.